Cerebrospinal fluid flow is a crucial aspect of brain health. It's produced continuously and moves around the brain and spinal cord. This flow is partly due to the constant production of the fluid itself, leading to a general movement, and partly due to the rhythmic pulsations of blood vessels within the skull. As the heart beats, the volume of blood inside the skull changes, causing a back and forth, pulsatile movement of the cerebrospinal fluid. During the contraction phase of the heart, known as systole, the cerebrospinal fluid flows towards the spinal cord. Then, during the relaxation phase, or diastole, it moves back towards the head. Changes in the normal dynamics of this cerebrospinal fluid flow have been observed in various diseases in both humans and animals. For instance, conditions like hydrocephalus and Chiari malformation in humans, and a similar condition called Chiari-like malformation in dogs, are associated with alterations in cerebrospinal fluid flow. Scientists can visualize and even measure this pulsatile cerebrospinal fluid flow using a specialized magnetic resonance imaging technique called phase contrast magnetic resonance imaging, often abbreviated as PCMRI. This technique works by using magnetic fields and radio waves to create detailed images of the body's internal structures, and in this case, it's specifically designed to detect and quantify the movement of fluids like cerebrospinal fluid. After an initial burst of radio waves, the phase contrast magnetic resonance imaging technique applies a fluctuating magnetic field, known as a bipolar gradient, in the direction of the fluid flow. This causes the moving molecules within the fluid to undergo a shift in their magnetic phase, and the extent of this shift is directly proportional to how fast the fluid is moving. The strength of this bipolar gradient determines the maximum speed that can be accurately measured, a value known as the velocity encoding. If the actual flow velocity exceeds this encoding velocity, it can lead to inaccuracies in the measurement, a phenomenon called aliasing. On the other hand, if the encoding velocity is set too high, the clarity of the image can decrease. Therefore, choosing the correct encoding velocity is essential for obtaining reliable measurements with phase contrast magnetic resonance imaging, and this choice depends on the expected speed of the fluid being studied. The application of this phase contrast magnetic resonance imaging technique has been demonstrated in previous studies involving healthy beagle dogs, where cerebrospinal fluid flow was measured at specific points.